luckily this video is all for you. So let's see if we can make it work this time. So I started by drawing our vectors. Hold on, let me unhook my clipboard here. So I started by drawing our vectors. So this one will be our vector u, and this one down here was really our vector v. And remember that we were told the bearing, the magnitude of u was 218, and the bearing of u was 22 degrees. And then we also were given the magnitude of vector v to be 170, and the bearing of that one, what was it? 112. Okay, so I drew those. So there is my 22 degree, right? The bearing for u. And then the bearing for v from here to here will be my 112 degrees, okay? Now, the magnitude of u is 212, so that will be the length of this vector. And then the magnitude of v here is going to be 170. But we want to find w, vector w, which is going to be u minus v, okay? So you had all of that right. You realize that this vector v has to go the other direction, right? So this is now going to be negative vector v. It's still going to be a magnitude of 170. Okay, so then what you were trying to do, and let's see if I can bring my ruler here. What you were trying to do is connect those two. So the u and the negative v to make that our vector w, right? So this is now going to be vector w, which is u minus v. Okay, and we had to find the magnitude of that vector, and so we had to figure a few things out. If this is the first quadrant, then this here will be a right angle, and the bearing of vector v is 112. So 112 minus 90 will give me that little chunk right there, and so that will just be 22 degrees. And because those are vertical angle right there, this will be 22 degrees as well, right? Because if you're looking here, that's two lines there. Those are vertical angles, so 22 and 22 degrees. And if that's 22 degrees, that means, let me change color again. That means that this angle right there will be 90 minus 22. But then look, if I keep going to go with my triangle, what am I adding? I'm adding 22. So we already had that figured out, right? If you recall, we already said this is going to be a 90-degree angle. So this is 90. And because it's a 90-degree angle, now I have a right triangle, so I can use Pythagorean theorem to find this magnitude of vector w. And so I'm going to say, well, vector w is then going to be equal to the square root of the square of the sum of both of the other legs, right? So it will be 212 squared plus 170 squared. And when I put that in my calculator, I found that vector W was equal to about 276. So that's our first measurement. And now we needed the bearing. So once we have that, I now have an angle here. I have that side is now 270. So I have 90-degree angle, 270 opposite side. And I want to know something about this angle right there. So I'm going to call that my angle beta. And I'm going to use my law of sine because I know the side opposite to my angle beta is 170, right? So I'm going to say, okay, then 270, oh, sorry, that should be 276, right, 276. 276 over, and the angle across is my 90, so the sine of 90 degree has to be equal to 170 over the sine of beta, and beta is what I'd like to find, so I'm going to cross multiply this, so I'm going to have sine of beta equals, and so that will be 170 times the sine of 90, which is really just 1, divided by 276. And then I'm going to do the sine inverse of that. So all of that inside the sine inverse. So my angle B will then be equal to sine inverse of that fraction. And when I put that in my calculator, I got that angle B is about 38 degrees. Angle beta is about 38 degrees. Okay, now that does not give me the angle, the bearing of W. Why? So let me kind of see if I can backtrack a minute. Go with light green maybe? No. Gray. I want the bearing, so I need to draw a new north here, right? So for that vector right there, my north will be right here. So this is what I'm going to call true north. And you're going to see in a minute why I call it so funny. I'm going to say this is the true north, right? But, back to my ruler here, my vector here, if I extend this side of my right triangle, I'm trying to match that, and I can't. Okay, I think I'm there. So if I want to draw that, extend this vector right there, you want to look at that as being an angle of rotation of your north axis, right? So see how this is where my right angle is, but it's been shifted from the true north by 22 degrees, right? Because that was our angle right there. So it's been shifted. So this right there now is my shifted north. So shifted north. And I'm sure there is probably a better technical way of calling that, but I think you understand what I'm trying to say here. And because my north axis has been shifted by 22 degrees, I'm going to have to account for that. So when I have beta, the bearing of beta would really go from here to there, right? So it will be 360 minus my 38 degree here plus my 22 there. So I would need 360 degree plus my 22, because I lost that, right? I had it shifted, so that was lost. And then minus my beta angle, because this is what my full rotation minus that, right? So minus my beta angle, which should be 38 degrees. And when I do that, I get 344 degrees. And that should be your bearing for vector W. Because vector W, let's see if we can extend U. Vector W, right? So this will be my vector W. Extended. So I don't know if I make much sense here, but this is the other way of doing it. Now, technically, we could go ahead and just do it the other way. So just the regular way without trying to connect those. So here will be my North Pole. And then somewhere here, let's just kind of make a horizontal axis, so we know where it will be. Okay, and now I'm going to draw my first vector U. So vector U was 22 degree bearing. So 22 bearing for my ruler there should be at 78. See if I can do it. It's too tricky. We're going to, can we just assume that's 78 here? Okay. So this will be our vector U, which has a magnitude of 218. And then we're going to subtract vector V. So now remember, vector V has a bearing of 112. So earlier in that example up here, we drew it way down there, right? We kept them both starting from the origin. But here, instead of doing that, what if, so hold on, I need to do, probably would need 22 degrees here, but let's imagine that's 22 degrees. So my vector U technically will be down there, right? But I'm going to just take that and it will go that direction toward the right. I'm going to take it and I'm going to use this and move it up here. In the negative direction already. So here is already negative vector V, and that had a magnitude of 170, if I remember correctly. Okay, So now the subtraction of both, so I would have u minus v, because v technically will go to the other side, so that's already my negative. So u minus v will then give me that new vector, w, which is what we need to find info about. And so w will be this one right there. And that's u minus v. Okay, now why is that kind of making it easier? We respected the bearing of everything, right? So we drew u first, and then we are doing a new north. And remember, those are all just parallel lines, right? Because north is north, no matter where you put it. And then I'm going to put my, oops. So that's just so I see where my new north is, right? So when I drew that, I had u was 22-degree bearing here. And then I'm up here now. So I drew that new north again. And my vector v needed to have, extend that, a bearing of 112. So from that new north, 112. And because we don't want it positive, we are going to go the other way. And so you just extend that line, and there is your negative v then. And you're going 117 magnitude, right? Whatever that unit is that we're using. This is what I have, and my vector w now is drawn there, and I would need to find that side. Well, we already know, and we can redo all the thinking, but we already know this is a 90-degree angle. We've done all of that earlier. So if that's a 90-degree angle, we know we can use Pythagorean theorem, and then we're going to do exactly, oops, see if I can move my paper. Are we stuck? Okay, it doesn't look like it's let me move my paper. Yeah, right there. We've already done that, right? We already did figure out in this area right there, using the Pythagorean theorem, and that will be exactly the same thing as what we've done, right? And so this will be same thing here, and so w will be equal to, actually that will be the magnitude of w. Doing the same work, it will be about 276. That's not changing, so we're still having that. And now that I know that this is about 276 and it's across from my right angle, I can use the law of sine again. And using the law of sine, I would find this angle right here. Let me change color so you can see well. Maybe green, this one. So the sine of 90 degrees over 276 equals the sine of, we don't know what that is, right? So I'm going to call it sine of some angle phi plus 22, right? That's the value of that whole angle together for that triangle. And then that will be opposite to the side y 170. And so when you're going to solve that, you're going to get sine plus 22. All of that is in degree. equals, so it's be 170 times the sine of 90, which again we already know is 1, divided by 276. And then you're going to put all of that in your sine inverse, right? So sine inverse of that fraction over there is equal to that. And now I want to know what that little chunk is here. So I'm going to subtract. So I'm going to put this in my calculator and let's see, I did it earlier. Where did I put it? Right there. So my angle plus 22 is equal to all of that in my calculator gave me 15.95, which I can really round up to 16, right? And then 16 plus 22 will give me that angle of 38 degrees. And then that 38 degree being all of that. And if I want the bearing of that vector W now, remember the bearing in that position will be measured from north all the way around until we reach that vector, right? So from north all the way around. So the only thing that wouldn't be in my 360 full rotation is this section right here, right? And that section right here will be this one. So the bearing will then be 360 degrees minus those, and I'm going to round that to 16. So minus 16 degrees, and that's going to give me my 344 degree bearing like we had earlier. Okay, so those are the two ways you can be doing that. This is probably the most straightforward, a more common way of doing it because we don't deal with any axis rotation here that we had to deal with here, which makes it really awkward and harder to think through and figure out without making any mistakes, as I demonstrated when you asked me in class. And I looked at it and I'm like, I need to think through that. All right. I don't know if I confuse you more or if that helps, but hopefully that's enough on that problem. And with more practice, eventually, when we do more on vector later in the semester, you're going to be, or in spring actually, I think is when we're going to do more on vector. Hopefully that's going to help too. All right. You have a good evening.